Assalamualaikum and good evening. My name is Muhammad Hakim bin Muhammad Ishaq and I will be presenting my group assignment number 2. Question number 1. By using mathematical induction, prove that for all integers of n is bigger than or equal to 2, 3 over 4 times 8 over 9 times 15 over 16 times ... which is the repetition of this sequence, times n squared minus 1 over n squared is equal to n plus 1 over 2n. Now there are 5 main steps to proving this question. First of all, we need to identify our proving method and use that proving method. This is easily done by checking the question itself. Already stated, by using mathematical induction, prove that. Underlined as well, by using mathematical induction. Second step, we have to identify the universe. For this one, universe are usually written as for all integers, etc., etc., or for all numbers of z, for z plus, for all real numbers. For now, we have for all integers of n is bigger or equal to 2. Now, the third step is we prove the result for when n equals to 2 or is considered the base case. Where do we get this number n equals to 2? It is from our universe. N is bigger or equal to 2. Hence, the lowest number it can go is 2. Now, our left-hand side is n squared minus 1 over n squared. We substitute it as 2, so we get 2 squared minus 1 over 2 squared. This, in turn, gets us 3 over 4. Now, our right-hand side is n plus 1 over n to n. Substitute n, and we get 2 plus 1 over 2 times 2, and then we get 3 over 4. At this point, we are now equal. Left-hand side is equal to the right-hand side, which means this result is true for when n equals to 2. Now we prove the conditional statement for when n equals to k is true for all k is bigger or equal to 2 using direct proof. This is the inductive step. Now we assume the result is true for when n equals to k, and then we substitute from our equation. N is now k. So n squared is now k squared is from n squared. Now this is then we consider the inductive hypothesis. This is 100% must right for our marks. Now next, from the assumption, we need to deduce the result is also true for when n equals to k plus 1. We use the next term of the left-hand side and we multiply both sides of the equation. Why do we multiply? Because this equation is in multiplications. 3 over 4 multiplied with 8 over 9. It is not 3 over 4 added to 8 over 9. Continue. This is the simplified version of k plus 1 squared. Okay, so if we have k plus 1 squared in the bracket, we expand the bracket, we will get k squared plus 2k plus 1. Minus with 1, we now have k squared plus 2k. We factorize k and then we get k plus 2. That is how we get this next term. Now, we continue developing the right-hand side of this equation. The right-hand side, why do we not develop on the left-hand side? Because there are too much numbers on the left-hand side. This is the much shorter version or the shortcut version. So we do the right-hand side for ease of answering. Okay, we have already established it properly. Now we k plus 1 over 2k. Since this is similar to this term is like terms, we can cross multiply it or cross divide it. Since k over k is 1, you can just cancel it, cancel a term of this, k plus 1 multiplied with 1, k plus 1, then we get 1 over 2, k plus 2 over k plus 1. We combine this term, we get k plus 2. K plus 2 is also equals to k plus 1 plus 1. And below we get 2 multiplied by k plus 1, which is now similar as if we substituted for the right-hand side n equals to k plus 1. Right-hand side, n plus 1 over 2n. Substitute k plus 1. Substitute k plus 1. We now get similar. Once this is similar, this inductive step is now completed. With this, we can finally conclude that this question has been proven by copying back the question with our method. Therefore, for all integers of n is bigger than 2 or equal to 2, 3 over 4 multiplied by 8 over 9 multiplied by 15 over 16 multiplied by multiplied by n squared minus 1 over n squared equals to n plus 1 over 2n by induction. Important to write induction, important to rewrite the terms properly. This is the full answer. Okay, so again, we say what we are proving, or the method we are proving, proof by mathematical induction. We state our base case, we complete our base case, we state our inductive step, we assume n equals to k, we have our inductive hypothesis, we use the next term of the left hand side, we multiply both sides of the expression, and we develop on the right hand side. And once the right hand side is similar to when we substitute n equals to k plus 1 into the term, we are now, the term here, we are now completed on the inductive step, and we can conclude that this has been proven by induction. Now we continue with question number 2. Consider the following statement for all integers n and all odd integers k. If kn plus k plus 1 is even, then n is even. Prove the statement above using contrapositive. There are 4 main steps towards this question. First, identify proving method. This have you done before. In here, the question itself says, prove using contrapositive. Hence, we must use contrapositive, or it's easier to use contrapositive. Next, consider the following statement. Again, we contrapositive the statement. So our method is contrapositive, hence we should contrapositive our statement. To contrapositive a statement, if P then Q, the contrapositive will be not Q, if not Q then not P. In this case, it is if n is odd, okay, the opposite of even is odd, or if n is not even, which means n is odd, then kn plus k plus 1 is odd as well. Third step, we prove the contrapositive. Remember our universe, for all integers n and all odd integers k, this will not be contrapositive, it will still stay the same. So let k be an odd integer, hence then k is now 2a plus 1. For some, a is an element of z. Suppose that n is odd, from this because we've contraposited it, n is odd, then n is now equal to 2m plus 1 for some m is an element of z. Now we continue. Kn plus k plus 1, kn plus k plus 1, we're going to prove it is odd. So 2a plus 1, substitute 2a plus 1, k, substitute n, 2m plus 1. This will be the substitution. We expand on the brackets, we completely put the statement, arrange the statement, then we factorize 2. Now we have 2, an element, or a subject, plus by 1 is also equals to 2m plus 1, where m is 2am plus 2a plus m plus 1, which is an element of z. By showing that 2m plus 1, we understand that this plus 1 means that this term will be odd. With this, we have finally concluded that this question has been proven by copying back the question with our method. Therefore, kn plus k plus 1 is odd, which completes the proof of the contrapositive. Hence, if kn plus k plus 1 is even, then n is even. This is the full answer for it. Okay, we start by proving. What proven method we're using? Proving is by contrapositive. We continue with let k be an odd integer. Remember, this is not contrapositive, only the statement. Then k equals to a. We prove the contrapositive. If n is odd, then kn plus k plus 1 is odd. Okay? Not q, not p. Suppose that n is odd, then n equals to 2m plus 1. Same thing we've considered. We wrap it up by concluding that this is odd, 2m plus 1 is odd. Hence, conclusion is if kn plus k plus 1 is even, then n is even. That is all from me. Atira will now continue with question number 3.